Hey guys, so welcome back to NTI. Um, okay, sorry about that. So, since Thursday was an early dismissal, um, for the first assignment for NTI, we're just going to be doing the assignment that was on Thursday since most people didn't get to do it. So, if you already did it in class, first or second period, then you don't have to redo it. But if you didn't finish it or whatever, you will. So during our live meet, we'll talk more about what to expect for NTI. But right now, I just wanted to go over permutations and combinations and sample space again. So, sample space is basically just a fancy way of saying all the possible outcomes. So, sorry, I can't spell. So if it says represent the sample space, that's not talking about coming up with a number. I know it says using set notation, but just ignore that part. Basically, it just means that you need to somehow list or represent all of the different possible outcomes that could happen. So I generally think a table is the most effective way to do this. So, for example, the chess club must decide when to meet for practice. They can do it Tuesday, Wednesday, or Thursday, and 3 or 4 p.m. So they can meet Tuesday, Wednesday, or Thursday, and they can do 3 o'clock or 4 o'clock. So that means they could do Tuesday at 3, Tuesday at 4, Wednesday at 3, Wednesday at 4, Thursday at 3, or Thursday at 4. Well, if you just wanted to list those off, you could, but if it says represent the sample space, it means you literally have to actually list off all of the possible things that could happen. So for the next example, a football player attempts 2 passes in overtime. Each pass attempt results in a completion, an incompletion, or turnover. So that means they could get on the first one they could get complete, incomplete, or turnover, and then on the second one they could also get complete, incomplete, or turnover. So that means they could get 2 completions. Basically, I just have to go through and say what could happen. Incomplete, turnover. So inside these tables, those are all the possible outcomes. I won't give you any like this where it's like crazy long list, so don't worry about that. But it's just important that you know what a sample space is and how to list all the possible outcomes. That'll come in when we start doing probability. So then we move into what we've been doing for the past few weeks. So if it says find all the possible number of outcomes, just the way this worksheet generator works, that's going to be fundamental counting principle. So every time something happens, you multiply by the number of options you have. So here, you spin a spinner 4 times, and it can be either red or blue. So there's 2 options per spin. So for every spin, you multiply by 2. Then you roll a 6-sided die. So you would multiply that by 6, which would be 12, 24, 48, 96, which is 96. Then for this one, it's different. Remember, if you're doing the same thing over and over again, that's where you have to, like, for the options, like you might multiply by the same thing multiple times. Here, I'm just choosing different types of options. So I have to choose a metal, and there's 2 kinds. So I'm going to take a 2, and then I have to choose a style, and there's 10. So I'm going to multiply by 10, and then I have to choose a gemstone. So this time, instead of like spinning a spinner or rolling a die, I'm actually making a choice. And for each choice, I multiply by the number of options. So that's the way you kind of got to think about it. Every time you do something, whether it's an action or a choice, you multiply by how many options there are. It's always multiplying by options. But this will end up being 120 different possible rings. Then you've got your permutations or combinations. So the main thing here is being able to tell which is which. So a permutation is where it's either going to talk about a specific order or, where everything you choose is different. So remember, permutations and combinations come from choosing out of a group. So if all the choices you make are different, then it's a permutation. If all the choices you make are the same, then it's a combination. So, for example, the student body of 40 students wants to elect a president, a vice president, and a secretary. Well, those are 3 different jobs. So that's going to be a P. Then the bigger number goes first. So I chose out of 40 and I'm choosing 3 jobs. So since you all don't have my calculators, if you have your own calculator, you can use that. Or you can go to Chrome. And I did this with people last year. If you look up permutation calculator, just pick the one that's both permutation and combination, and you just put the 2 numbers in here. So it was 40 and 3. And it'll give you both. So the permutations is 59,280. 59. It just does that formula for you. This one, 3 out of 14 students will ride in a car instead of a van. Well, they're doing the same job. Or I'm sorry, they're doing the same thing. They're all going to ride in a car together. So that would be a C. If it's a P, it'll like explicitly say the different things, or it'll talk about being in a specific order. So remember, the bigger number goes first. How many you're choosing out of, and then how many you're choosing goes second. So I'm going to come back over here, change this to 14, and it was 3 again. This time it's combination, so that's 364. So this is the stuff that's on the assignment today. Please make sure that you come to the live meets so that I'll have stuff to talk to you about there with NTI stuff. But anyway, hopefully we will get back in person soon. Okay, that's all.